The topic is Basic Tools for Economic Analysis, and we are going to consider charts, measure of central tendency, and measure of dispersion. Topic: Basic Tools for Economic Analysis. 1. Charts. Specifically, we are going to look at pie charts. By definition, a pie chart is a cyclical diagram in which each sector of the circle represents a given data in the distribution. Example 1. We have a pie chart here represented. These are the various sectorial angles. Here the student had pass, 120 degree, credit, 80 degree, very good, the angle is not given, excellent, the angle is not given. Now the question proper. The grades of 36 students in a test are shown in the pie chart above. How many students had excellent? A 12, B 7, C 8, D 9. Solution. First, the total of pie chart is 360 degrees. Total of pie charts equal 360 degrees. The portion for very good equal 90 degrees because it's a right angle. Then the portion for excellent portion we give 360 minus 120 plus 80 plus 90. And of course, that will give 360 minus, if you add all this together, give you 290. So the angle for excellent will be 70 degrees. So, to calculate the number of students that got excellent, we say, therefore, 70 over 360 times the total number of students, 36 over 1. And of course, if we cancel, we are going to get 7 students. Answer equal B. Two, measure of central tendency. A, mean. The mean we are talking about here is arithmetic mean. Simply defined, mean is the average of a given distribution. Now, mean, x bar, of a set of numbers like x1, x2 to xn is the same thing as the mean equal x1 plus x2 plus xn over n, where sigma is summation of data. The data are x1, x2 up to xn, n number of items. Example 1. Find the mean of a set of numbers 4, 7, 3, 6 and 0. Options: A 8, B 3, C 5, D 4. Solution. Mean or x bar, mean equal sigma x over n. That will be 4 plus 7 plus 3 plus 6 plus 0. 0 is also a figure, all over 5. And that will give us, if we add all this together, give us 20 over 5. Now give us 4. So the correct option is D. So right answer equal D. B. Median. The median of a set of numbers arranged in ascending or descending order is the middle number or item. If the total item is odd, if the figures given, you count them, is odd, then median equal n plus 1 bracket divided by 2. Note properly, the median here is n plus 1 bracket. This is the third item, which means this n will be whatever the figure that is in the middle plus the next item, that is the th that we have here, divided by 2. Then if the total item is even, median is n all over 2 brackets item. So the n here will stand for the 2 middle value divided by 2. That is the mean of the 2 middle value. Example 1. Find the median of the following set of data: 3, 8, 6, 2, 1. Options: A, 2, B, 3, C, 4, D, 6. Solution. We must rearrange. So we say median equal 1, 2, 3, 6, 8. Ordinarily, if you look at this, this is odd. This is odd. 1, 2, 3, 4, 5 is odd. So ordinarily 3 is the median. But if we apply the formula, but using the formula median equal n plus 1 are 2 items. The next item to the middle value here is 6. So divide 6 by 2 will give you 6 all over 2 equal 3. Answer equal B. Question 2 or example 2. What is the median of the following set of figures: 4, 8, 6, 2, 1, 4. Options: A, 8, B, 6, C, 4, D, 24. Solution. First of all, we rearrange in either in descending or ascending order, but we are using ascending order here. So we write median equal 1, 2, 4, 4, 6, and 8. Counting 1, 2, 3, 4, 5, 6. we see that the total figure is even. So we can use the formula median equal n over 2 item, which means we look for the two middle value and find the mean. Therefore, 4, you count 1, 2, 1, 2. So 4 and 4 are the middle value. So we add 4 and 4. So we add, therefore, 4 plus 4 all over 2 equal 8 all over 2 equal 4. Therefore, the answer is option C. C. Mode. The mode is the number that occurs most in a given distribution. Example 1. Find the mode of the following set of figures: 4, 3, 7, 8, 10, 8, 13. Options: A, 4, B, 7, C, 8, D, 13. Solution. Since we are looking for the figure that appears most in the distribution, it's better we rearrange so that we can write mode as mode equal 3, 4, 7, 8, 8, 10, 13. And so 8 occur most. Therefore, mode equal 8. Answer equal C. Example 2. What is the mode for the following set of items: 2, 4, 5, 4, 6, 8, 7, 8? Option: A, 2 and 4, B, 4, C, 8, D, 4 and 8. Solution. So we have to rearrange the figures for convenience sake. So we have mode written as 2, 4, 4, 5, 6, 7, 8, 8. If you look at the board, we have 4 occurring twice. We have 8 occurring twice. Therefore, mode equal 4 and 8. Answer equal D. The main topic here is measure of variation or dispersion. The measure of variation or dispersion is the degree to which data are scattered about or around the average value. Examples of such measure include range, mean, deviation, variance, and standard deviation. A. Range. Given, range R is defined as H minus L, where H equal highest figure in the distribution, L equal lowest figure in the distribution. Example 1. Find the range of the numbers 14, 40, 10, 18, and 15. Options: A, 40, B 30, C 15, D 10. Solution. Range R is given as H minus L. Now H equal 40, that's the highest figure in the distribution. L equal 10, the lowest figure in the distribution. Therefore, 40 minus 10 equal 30. So the answer equal B. Example 2. What is the range of the numbers minus 1, minus 2, minus 4, 1, 7, and 4? Options: A 8, B minus 1, C 11, D 3. Solution. We are now conversant with range, so range R equal H minus L. H equal 7, that's the highest figure. The lowest figure there equal minus 4. Wanting with negative figures, the bigger they are, the smaller their value. Therefore, we have 7 minus 4. Of course, 7 minus we turn to positive. So it will now give you 11. Therefore, answer equal C. B. Mean deviation, MD. The mean deviation of a set of numbers x1, x2 to xn is defined as MD equal sigma bordered x minus the mean of x, where x equal mean of the numbers, the given numbers, and x minus x mean, which is border, is the absolute value of the deviation of x from the mean of x, which makes the negative number automatic positive. This is the modulus, so that once it is bordered, whatever negative that come out of the solution become positive. Example: calculate the mean deviation of the set of numbers 7, 3, 14, 9, 7, 8. Option A, 2, 1 over 6. B, 2 and a half. C, 1, 1 over 6. D, 2, 1 over 3. Given MD, mean deviation equal sigma bordered x minus the mean of x all over n. But define the mean of x equal x sigma x over n equals sigma x over n. That means taking the figures equal 7 plus 3 plus 14 plus 9 plus 7 plus 8 all over 1, 2, 3, 4, 5, 6 all over 6. This of course will give 48 all over 6. and the mean equal 8. We can now solve for the mean deviation. By doing that, we say MD, mean deviation, equal, we'll draw a table for that. X, the number of figures in the distribution. We have X minus mean of X, that is the deviation. Then we look for the absolute deviation, which is X minus mean of X bordered. So looking at the question, the figures are 7, 3, 14, 7, 3, 14, 9, 7, 8. You can extend this. Okay. Since the mean is 8, so we do this operation, x minus mean of x. So 7 minus 8 will give minus 1. 7 minus, that is 3 minus 8 will give minus 5. 14 minus 8 will give 6. And 9 minus 8 will give 1. 7 minus 8 will give minus 1, and 8 minus 8 will give 0. Now we look at the bordered x minus the mean of x, which automatically make it positive. So minus 1 will be positive 1, minus 5 will be 5, 6 will be 6, 1 will be 1, minus 1 will be 1, and 0 remains 0. If we sum up sigma x, of course border minus the mean of x, will give us 14. Therefore, the mean deviation equal 14 all over 6. Equal to 1 all over 3. So the correct option is D. C. Variance and standard deviation. Roman figure 1. Variance denoted by V. The variance of a set of numbers x1, x2 to xn is given as V equal sigma x minus the mean of x squared all over n, where n equal number of data given, then sigma x minus the mean of n squared, it is square of the deviation. Roman figure 2, standard deviation, SD. By definition, standard deviation is the square root of the variance. That is, SD equal the square root of the variance. Example, find the variance and standard deviation of the scores 1, 2, 3, 4, and 5. Option A, 2 and 1.414. B, 2 and 44.14. C, 2 and 4.144. D, 2 and 14.144. Variance. 1. Variance V. V equal sigma x minus the mean of x squared all over n. But we have to define x bar. But mean of x equal sigma x all over n. So mean of x equal, add the numbers, 1 plus 2 plus 3 plus 4 plus 5 all over 5, because the items are 5. That of course will give 15 all over 5, and the mean is 3. Now we can look for the variance by constructing a simple table that will give us x minus mean of x squared. So we say variance equal x, that is number in the distribution, x minus mean of x, and x minus the mean of x squared. Have 1, 2, 3, 4, 5. Good. X minus the mean of x. The mean is 3. So 1 minus 3 will give us minus 2. 2 minus 3 will give us minus 1. 3 minus 3 will give us 0. 4 minus 3 will give us 1. 5 minus 3 will give us 2. So to get this column, we need to square this. So if we square minus 2, minus 2 square will give us 4, minus 1 will give us 1, because this will give us 0, give us 1, 2 square will give us 4. So sigma x minus the mean of x square equal, we add this to this 8 plus 2, 10, equal 10. Therefore, variance equal 10 all over 5. 5 is n. And that will give us 2. That's the first part of the question. The variance is 2. For the standard deviation, SD equal the square root of the variance. Therefore, we have the square root of 2 equal 1.414. the variance is 2 and the standard deviation is 1.414, option A is correct.